Let me start us off just by saying that we are infinitely grateful to have the legend himself, Todd Underwood, with us. I am joined by none other than Vishnu. He is making another cameo. David, or our other amigo David, couldn't be here today because I'm going to throw him under the bus right now. His wife is taking a legal exam and told him that he cannot be on a talk while she has taken the exam because it would distract her. So he's
That
sitting at
seems
home.
legit. That just seems legit. I'm in favor of this.
Exactly.
It is definitely a legit excuse. It is also completely driven by work from home life.
Yeah,
I cannot think of a more work from home life thing problem.
Exactly. That's it. You may see it's the way that it works, right? Like you may see my daughter pop up into the screen, and that's just life these days. 2020 has been like that.
Yeah.
So, Todd, this is going to be a bit of like a parallel conversation, I think, or like a perpendicular conversation. You can tell that I know my geometry quite well, obviously, but I've been enjoying two of your, I think it's the OPML talks that you gave. One was at like SRE Con, and the other was fairly recently about how machine learning breaks. And so I want to kind of weave both of those into this conversation and just have this be like the after hours session of those talks, if that's cool with you.
Absolutely.
I think we should probably start, though, just by giving people a bit of background on what you're doing, what you've been up to for the last 10 years. I know you have over a decade of experience working at Google, and you're currently doing a lot of stuff around the maintenance of machine learning. And I think your technical title is SRE of ML. Is that it?
Okay. Yeah. So a little bit of context. So I came to Google here in the Pittsburgh office in the eastern part of the US. People outside of the US don't really know that much about Pittsburgh, but it's a sort of a ex-industrial city. It's sort of the Sheffield of the US if you want to map it into the UK, maybe Leiden, I'm not sure. But an old steel town, part of the US Rust Belt. And pretty storied tradition here of, sort of hard industrial work, but really hit hard during the economic downturn, when steel started internationalizing and, the US lost most of its steel manufacturing, really impacted this whole region of the US. And Pittsburgh pivoted hard into education, in particular the medical industry and higher education. They already had Carnegie Mellon University. I didn't go there. I'm supposed to be sad about that. They're the #1 alumnus institution for Google, for the engineering organization, like more than Caltech, more than Stanford. It comes from CMU.
Wow, I didn't know that, considering it's not the biggest school in the world. Wow,
no,
that's
not
crazy.
at all. Not at all. I think, what I've learned since being here is CMU's had a really different approach to computer science for a long time, and its approach some other schools are starting to pick up. So most sort of institutions of higher education treated computer science either as an offshoot of math or an offshoot of general engineering. And they're like, oh, you can have a little department inside of the School of Engineering. What Carnegie Mellon did is they said, no, we're going to set up an entire school of computer science with sub-departments for robotics, for machine learning, for biotechnology, for technology related to business and related to society and government. And so they had this very much applied notion that we are developing pure algorithms. We are looking at, core technology, but ultimately we want to be a little bit more inspired by the way those things apply in the real world. And I think like one of the things that we've seen come out of that in the industry writ large is in the field of robotics, where people are like, I can do computer vision, like, cool, but all of the problems are actually like really weird edge cases. Like all the problems are you can detect people, but not if they fall down in front of your car. Actually, you need to detect the people if they fall down in front of your car. Like, well, that's hard because that looks kind of like a cat. And you're like, well, actually, you probably shouldn't hit cats either with your car. I say this because Pittsburgh is sort of the global center of autonomy. We have 4 self-driving car companies that start with the letter A testing cars on the road here. That's just 4 that start with A. So we're doing a lot of self-driving here in the city. And so anyway, so I came to Pittsburgh, and the job they had for me, my background is in systems and network engineering. I had been chief technology officer at a small internet service provider in New Mexico for a number of years. Back in the dawn of the internet, like we had a statewide network before there was an internet, and we plugged the internet into it. Like the National Science Foundation came to us and were like, hey, you seem like you have a network. Can we plug this internet thing in? I don't know, seems legit. We'll try it, see if the kids like it. So that's what we did. And so my background was all systems and network engineering. And I came here and they said, we have this data processing pipeline for targeting ads. You should probably figure out how to make that work reliably. And say, okay, how hard can it be? How hard can it be? How hard?
Famous last words.
So yeah, 11 years later,
Still working on it.
my role now is head of ML SRE. So I actually founded the group globally to do reliability engineering for SRE at Google. So we have two halves of it, sort of internal and external. So half of my staff work on the cloud AI stuff, which all of the problems are the same, but the context is really different, right? Like one of the things we try to be conscious of is things are a little bit different at Google. It's not better, it's not worse. They're just like sometimes we have problems that are far simpler, and sometimes we have problems that are far more complex. So, concretely, we have a massive amount of data, but because we are one tightly knit engineering organization, we can collaborate in ways. So like if you write code that breaks my application, I just like message you and like, hey, your code broke my application, please roll it back, and you do. But that's not how like if you're another corporation, like I need to have nothing to do with you. And the use cases externally, far less data, but far more complex use cases and far less simplifiable or predictable use cases. So we've got the cloud side now. We've got the internal side where I think, lots of people you all have talked to over the years, I'm sure like the tradition is, I have a problem, I build a model. I want to keep updating my model. I'm going to build some infrastructure to update my model. Okay, now I'm an infrastructure team for my model, and so is everyone else. So now, and we saw that too within the different product areas at Google. Like you would have multiple teams inside of the geo group doing machine learning, multiple teams inside of search doing machine learning, multiple teams inside of ads doing machine learning. But the ads folks, because they're money oriented, they're a profit center. So they're like, that's too expensive. So years before many of the other product areas, they were centralizing infrastructure for training, for quality analysis, and for serving. And so that's why I got my start on the ad stuff. So there's a little bit of context. I don't know, what did I leave out, or what did I not hit that would be useful to hear about?
I mean, I think you got it all in there. One thing I really love that you seized on and mentioned is that things aren't better at Google, they're just different. And I think a lot of times, in our conversations that we have in the community, I work at a small startup for context, we're looking at the Googles, we're looking at the blog posts, and they're saying, man, we want to be there someday. And it's helpful to hear someone like you who's been there for so long say, hey, we know we're different, you should know we're different too. Mm-hmm. My question to you is, and this is kind of getting into the content of your talks, which I love for their practical, no holds barred description of reality is, for a lot of us sitting outside Google, where we want to go is what Google is doing. Mm-hmm. You're at Google. You're leading a group. You're leading a team that's doing industry cutting edge work. What's the vision of the world that you paint for them in terms of where you would like SRE and ML, or just in terms of building strong systems in ML that are not failure prone in any sense or anything like that? Like, what kind of vision do you paint? I'm curious.
Yeah. So when I think about this problem, I want to highlight, I think we're at the very beginning of this. So when I talk to people, I don't have my undergraduate degree is in philosophy. I have a graduate degree in computer science, but it's only a master's, and it's in network engineering. It's, it was pre-TCP offload segmentation doing that. We were doing that to prove that this was good for receive side interrupt mitigation. That has nothing to do with machine learning. Okay, cool. So I'm sitting here I can talk to you about Wittgensteinian skepticism about meaning and what Kripke said about that, and we can talk a little bit about that, or we can pick up how the Alteon ASNIC cards back in the day where it had a MIPS 4000 series processor, but not again. So then bring this to machine learning. Well, what we see happening in the industry is I think that NeurIPS, the focus on machine learning is always algorithmic. It's always at the development of new algorithms, the development of new model structures, because that's at the beginning too. But what I find is that like inside we think of it as productionization, but the commercialization of useful technology is lagging so far behind. Like the cutting edge techniques that aren't baked into software, that aren't baked into services, that normal people can't take advantage of, aren't that useful. They're super useful for, Baidu and Amazon and Facebook and Google and Microsoft, who can like hire, 20 or 30 or 40 PhDs and roll up a system with the latest. Like when you see the BERT stuff, you're like, okay, cool. Google did BERT, great. And honestly, the idea of adding vectors, semantically meaningful vectors is cool, right? You're like, how do I put and it's problematic as well, but how does that help? Like, what is that? What is the use of that beyond a huge search company, right? Yandex can take advantage of that, great. But like, can you? Like, I don't know. Like, is that a useful? Whereas at the same time, what I see is it's the barriers to innovation. So I see like, I see smart engineers without a machine learning background who are doing something else. Like they're working on docs, or they're working on an online tax processing application, or they're just doing something else. They're building an application. They're running a factory. They're running they're running SAP for their company to try to predict the manufacturing inputs and outputs. Okay, so what does machine learning do for those people? And the answer is right now, not a whole lot. Like it's too esoteric. It requires too much specialized knowledge. It's not packaged. And so the offensive thing to the people who know more about this than I do and care more about this is I actually think the algorithms aren't interesting, because I think we have too much backlog of useful technology that hasn't been made available to enough people. And so I'm less interested in the cutting edge of algorithms, in part because maybe I'm not that smart, in part because like way awesomer people are doing great work at that, and I trust them and I wish them well. But I'm more interested in how do we get the junior engineer 6 months, like she is a software engineer working in a new role or a new company. She's been on the job for 6 months. So she kind of knows the landscape. She shipped a few features. She's got an idea. She's just sitting there. She's like, I want to make this better. And here's how. I read about some stuff. Like has a basic familiarity with, unsupervised learning or supervised learning, basic idea of what you can do, but nothing beyond that. How do we go from that to, I got a junior engineer working on an application with an idea and some data. And within a short amount of time, and my objective would be within a week or two, has a functional experimental model that can do or not do something in a production ready environment so that iteration can happen. And I will say, honestly, like that's my goal inside and outside of Google. We also don't have something that is that easy, that is that sophisticated, that is that generalizable. So that's where I think, like, that's what I'm excited about. And I'm excited to see where we go with this. Like one of the reasons I was interested in this conversation, I'm interested in this whole idea, whether we stick with, this particular approach to it or not, is the idea of MLOps. Like, I don't love operations because there's some negative connotations for me, but I love the idea of productionization of these technologies being a separate task that needs to be done on itself, because it enables innovation, not because it makes things just reliable, or not because it takes things that already exist and makes them boring, but because it creates new things that haven't been put together yet. So I'm excited about that. I think we're at the very beginning of that.
That's so interesting that you say, and I think you're preaching to the choir here on like the algorithm is, as I just interviewed this guy, Joe Reese, last Wednesday, and he said, the algorithm is the easy part in his mind. It was like actually getting that out and making business, like getting business value from that is the hard part. Yeah. And really where he feels like, just like you said, and I love this sequence of events. It's like you start with an algorithm, or you start trying to tune something, and then you go on to the infrastructure, and then you go on to seeing like, hey, how can I have this work for me? And so it's fascinating to think about that idea. And we see it in the landscape, right? There's so many different tools that are trying to come up to make this jump that you're talking about, this junior engineer who's been at the job for 6 months and she has an idea and she can now put something into production a few weeks later. Yeah. Like that is everyone's goal. I just wonder, like, playing a little bit devil's advocate here, do you really think that's possible?
Yeah, I do. I do, because I think so. So hard, you only do hard things like when you decide to do them, and then they look hard, but you break them down in steps. So let's just break it down. Like, what do we need for that? Well, okay, like, so, what's the beginning of that and the end of that pipeline? And let's talk about what's in the middle. Well, at the beginning is an idea and some data, right? So we're like, oh, okay, well, having some data already that's a barrier to a lot of organizations that I've talked to inside and outside of Google, for sure.
And like, having enough data.
Yeah. Well, do you have your data? Do you have enough data? I mean, yeah, I do see, but like, that's actually, so I think just as a little, diversion here, I think ML gets a bad rap on that because I think in particular, enterprises have been overestimating how much data they had and the value of that data for decades. I remember working with, I won't say who, but a large power company in the US who had an Oracle database with a single table with like a few 100,000 rows in it. I'm like, that's a spreadsheet, kids. Like, that's not an Oracle data. And they were spending like $500,000 a year on that software. I'm like, you can do that over on that desktop right there. Like, what are you doing? And they're like, no, it's enterprise grade. It's serious. So I think like this idea of like, do we have a lot of data? Like that happens like all of us sort of, and I see it happen inside of Google where people are like, we have a lot of data. And I'm like, cool, does a lot have a number? And like, sometimes you'll see two people who say they have a lot of data and one of them has like 16 petabytes and one of them has 5 terabytes and one of them has 100 gigabytes. And I'm like, well, okay, those are actually just different. Those are really different numbers. But anyway, so data, you need enough data and you need to know what it is. And at the end of it, you need a model that is served, a model where you can look up something in it. And that could be like a batch process where you throw a bunch of new examples at it and you get categories out of it because it's, that's what it's doing. Or it could be a prediction, categorization labeling system. So that's what you need. The steps between there, like at a simple basis, they're not that complicated, right? You need a data acquisition system, you need a metadata system, and that'll come in later. You need a feature storage system and probably a model storage system and a model metadata system. You need a training system. You need a quality analysis system and a, syncing to serving, gating the syncing to serving, and you need a serving system, and you need to loop those things together. Okay, I mean, I know that's a lot, like each one of those, you're like, each one of those is a lot of stuff, which it is. But in the end, it's also just a thing, right? And so I think that the secret here isn't, can we do this? We can do this. Lots of entities can do this. And collectively, the internet, like as my friend says about Wikipedia, it's proof that the internet has a lot of spare time on its hands. The internet has a lot of spare time on its hands. So
absolutely.
Right? So we can do this. The question is really, can we get organized around a narrower set of use cases? And that's where I see the problem. Just like the algorithms folks, the systems folks, we talk ourselves into, well, it has to be able to do everything. No, it does not have to be able to do everything. We need to make, and this is the problem where we don't have enough product leadership in this space, because a lot of people who are engineers are like, I am an engineer. I don't want to talk to product managers. That would debase me. I'm like, well, but what we need to decide is what are the most common use cases and what is the smallest collection of those that can meet the largest number of needs? Because that's where we should start. And I think these are like, there are simplifying assumptions we can make, but to do that, we're going to leave out people. And so people are clamoring to not be left out. And as a result, we're not making as much progress as I'd like to see. So, but I think this is doable. Sorry for the rambling answer, but I think this is absolutely doable. I just think that we need to make some tough product choices to get the earlier versions of these things out the door.
I know Vishnu has a question. I see him itching to ask, but I just wanted to ask before to jump in and snake him on this is this idea that, I mean, you laid out a few things there, right? And we were talking to the head of ML at Monzo Bank, and his whole theory on it was like, just get something out. It doesn't matter if it's perfect or if it's the maturity level 2 and you don't have a feature store and you don't have like the monitoring. Just start serving, see if you can make sure that there is a possibility to get it out. I want to know how you feel about that. Like, does it need to be all shiny?
No, absolutely not.
Ready?
No, strongly agree.
Okay.
on one of our internal systems. So you think about that pipeline that I just described, the sort of left to right data in and serving at the end and everything in between. On one of them, we started at the end. We said, here's a serving system. And we did that for two reasons. One reason was TensorFlow already existed, and some TensorFlow training frameworks already existed inside of Google. And so people had adopted those with these bespoke pipelines. So their own orchestration, their own like data storage, and like it just like people just did some stuff. But at the end, they produced this saved model format where they're like, okay, like whatever happened before this moment, I have a saved model. We're like, cool, what we'll do is we'll build a global, incredibly high throughput, really reliable serving system. Now it assumes that all this other stuff exists. And like, if that other stuff didn't exist, that would fail, right? If I declare, here's my serving system for things that people can't produce, well, that's not going to be a very popular serving system, right? But this was the serving system where people were already producing it. And the benefit of that was it was a very narrow, like it's a small problem. I'm not saying it's not like it is now a very, very, very large serving system because it's enormously popular inside of Google. But at the time, we're just like, I don't know, it's a serving system. You give us a model, we look up answers into it, we copy it around the world. We have, TensorFlow model servers that look things up in it. It doesn't do that much, but the stuff it does well. And so totally agree. That's a completely reasonable approach. But then the question is, like, I think what we learned from that is the value is the APIs, the value is the interfaces. And so you look at like a file format, that's just an interface, right? It's a set of constraints. And so I think what you're going to see is let's define boxes of functionality and let's define as clearly as we can APIs before and after. And then let people, which actually solves the customization problem because you're wandering through this pipeline and you're like, I don't like your box here. And you're like, cool, you don't have to like my box. You have to take the thing that comes out of this thing, do something to it and produce the thing that goes into this thing. I don't really actually care how you do that. I can't make reliability guarantees about what happens when you wander off and go run some code on some computers and hope for the best. But I can actually make reliability guarantees about the segments before and after that point. And so even then you're providing some value when people want to, jump out in the middle of the pipeline. So I totally agree.
I mean, I think that point of, I don't like your box, I think that summarizes like 99% of the complaints that anybody has with any ML tool, with any ML framework, whatever it is. I just don't like the way you set up, your process. And I have a different opinion on how to do it. Right. And I think a lot of the kvetching that goes on in the community about, how we are doing machine learning or how we could do it better, particularly compared to other software engineering things, it's just that we haven't coalesced around that a vision of like, okay, what are the boxes, right? And those standards are being set. I want to go back to what you said about product leadership and the kinds of people that need to be involved in order for machine learning to be, to realize its potential for all the people that can use it. I think one, as just a short observation, the machine learning hiring process and how that gets done is kind of odd, right? I mean, in the sense that we have this ML scientist, we have the amorphously defined ML engineer, and then we bring in, software engineer, machine learning, we have site reliability engineers, we have all these different roles. Now MLOps is becoming a thing. I wouldn't be surprised if, we start to see MLOps engineers. I mean,
data engineers.
Data engineers get a part of it. So, I mean, with all these different titles, I think it's hard for particularly companies that think about, structured organizations, right? And org charts in terms of how to make ML useful in the context of an org chart, right? Yeah. How do you think about that challenge as you build, your team for, at Google? And, what advice would you give to other people who are trying to bring in ML professionals into their companies to make ML useful for them?
Yeah, I think it's a really good and important question. And, in one of my other hats, I run the hiring committees for SRE for Google globally. Wow. And so I spend some time thinking about staffing. I think so. We're really fortunate. There's a lot of smart people out there and a bunch of smart people want to work with us. And I think I don't want to underestimate the importance of just having really capable people who are really excited to learn, because that's not, I'm not saying that there aren't a lot of places where that's true, but it's not true for every company in every, location and every role. And so I'm pretty cognizant of that. But I think I think we need to remember that this is also not different from some other subfields in computer science. So you think about like how obsessive, HR professionals were about people knowing some particular version of Java. And you're like, really?
Yeah.
Is that the thing they need to know? Or like how many people are really getting jobs because they're Ruby on Rails expertise today? Like, and how many people were hired because they're, I am the Ruby on Rails genius. And so, and I over and over again, like, do you know some particular version of Cisco iOS? Or do you know like some particular version of, this particular, Ingress database going back in the day? And like, so I think like as an industry, we should recognize we're doing the same thing a little bit, and we should stop and we should think about, well, what can people do and what can they learn? Because like, I think, I call this the sort of MySpace problem. MySpace was going to be forever until it was gone. And so much of the internet is like, everything's changing all the time, but we're all convinced that the today is the future. Like today's tomorrow's past is actually like, everything's going to be different, but it feels like the omnipresent future. Like it's all going to be like this, but it's not, right? Like ML infrastructure, jobs, is not going to look like this in 5 years. And I want people to be thinking like 5 years, because you don't hire people for 6 months. I mean, if you're lucky, you can keep people for a few years. So that's why I think 5 years. Like, well, in 5 years, what kind of skills do people need? And so when I think about my teams, like most of the people who work on reliability engineering for machine learning at Google do not have a machine learning background. I would say that there are like, somewhere in the neighborhood of 5 or 8% of the people globally working on ML reliability engineering who have any graduate level education in machine learning, at the master's PhD level.
That's huge.
And you're like, that's wild, right? Like, this is like, Google does a lot of this. These are the people doing it serious at scale. Like, why is that? Because, and I think the issue is, like, let's go back to talking about how machine learning pipelines fail. Machine learning pipelines do fail in some idiosyncratic ways, but those are ways you can learn. Like, I don't have a PhD in machine learning, and I'm like, well, what I know is subtle changes in the distribution of the data affect these outcomes in ways that normal data processing pipelines are not affected by that. But like, cool, like that's a thing you could just learn. Like, it's not impossibly complex. You do not need a PhD in machine learning to know that. But what you do need is some thoughtful understanding of how the dependencies of the pipeline have changed to be much more dependent on the data itself than some other data processing pipelines. So if you're computing tax tables, or you're like calculating how much people owe, you're like, if I change every third 7 to an 8, you'll get wrong answers, but it won't be subtly wrong in a way that's difficult to understand, catastrophically bad in some cases, and really like fine in other cases. Whereas if I drop all the data from Latin America, well, then I'm going to think Spanish is only spoken in this weird, like, now apologies to the people in Spain, niche accent from some European country. And I will draw wrong conclusions about vocabulary, about what people buy, about what people search for, and what people care about, and globally, I might have only dropped 6% of my total data. And I'd be like, it's fine. But like now all of a sudden, everything is wrong, but everything is completely wrong for a small subset of people, and everything's fine for like English speakers in Canada, or like, like they won't even notice that anything went wrong. So anyway, like, I guess going back to the hiring point, I try to hire for people who are excited to learn this stuff, much more than I hire for people who have a deep formal background in it. I do think it's valuable to try to learn how to read academic papers. But I actually think that's valuable in, systems in general, in software engineering in general. I think like Papers We Love has a cult following because it's enormously helpful to learn how to read papers. And so, maybe there's a little bit of that.
Well, I think it's huge that you're talking about 5 to 8% of the SREs that are working on machine learning at Google don't have machine learning backgrounds, because so many times I see people coming into the community and asking, hey, how much machine learning should I actually know here? Like, I'm coming from software engineering. I don't know what I should know. Should I like learn how to train a model? Like these kind of things.
If I had a dime for every time how to learn deep learning and AI, an article on that was posted on Medium and Hacker News, I would be richer than Elon Musk. I mean,
it's amazing.
And I do think like, so when I think that, I'm like, is it useful to train a few models? Yeah, it is. Of course it is, because it gives you empathy for your users. But I think like, I think it's right to think about modeling teams as being a separate subspecialty. And so I think what we're doing is we're reifying and centering modeling and saying like, the people who know how to construct models, that's the important part of our whole industry. And everything else is just something else. And I'm like, well, that's a little bit strange, because if we're good at this, if we're successful, so let's pretend this stuff works, because sometimes it does, right? I've noticed this. Occasionally the machine learning works a little bit. So let's assume it works. We're going to want to use it for a lot of things, right? If we want to use it for a lot of things, the biggest problem in machine learning is going to be building and operating serving systems for it. It's not going to be modeling, because every single model you build, you will look up 100 times, 1,000 times per operation you spent in training, 1,000,000 times, right? So what's the actual at scale problem with machine learning? Building scalable serving systems. What's the next problem? Detecting subtle quality problems before you ship them to those scaled out machine learning serving systems. Okay, neither of those problems, like the second problem does have like, you need to think about how do you do subslices of, if you don't know what a golden set is, or you don't know how to talk about, aggregate loss in subslices, or, you wouldn't know how to look at subsets of your data. Well, okay, you're probably not going to get very far. So if you're basically like, if you're a sysadmin who's never really thought about data, you're going to have a really hard time doing something sensible with that quality piece that I just measured. But I think like, if you're curious about those things, it's not, as the rocket scientists I know say, it's not brain surgery, as the neurosurgeons say, it's not computer science. Wait, it is computer science. Everybody thinks something else is harder. But I do think like, it's a thing we can learn, and we should learn it. So I think like, if we're successful, we need many, many more people who can make sensible choices about how to productionize these pipelines and keep them running. And those are going to be people who are thoughtful about data storage systems, and people who are thoughtful about scaled out, pipeline processing systems, and people who are thoughtful about serving systems. And like, how many modeling folks do you need? You need some, but they're the small minority if we're successful.
So do you feel like there will be a point, like going back to this idea of there's not enough product managers in the field right now, and we don't have a standard like operating procedure. Do you think that it will be a point where we'll get to, maybe it's a year down the road or 5 years down the road, where it's like, okay, yeah, if you want to do machine learning, this is the standard way of doing it?
So I think there will be more standard ways to do it, but I think you already see this at the libraries and framework spaces, right? So when TensorFlow shipped, like, was TensorFlow easy to use and understand? Did everybody it was for like, as far as I can tell, Jeff Dean like computes graphs in his head and thinks this is a really straightforward way of representing problems. And the rest of the world is like, I don't, wait. So what happens here is like, well, then you compute the graph, and then the things happen, and you're like, okay, right? So, but was it enormously popular? Yes. Okay, why? Well, it was a complete solution that worked, that had pretty clean interfaces. Like, you could understand how to use it. You might not be able to understand, like, it might be tricky to troubleshoot. It might be hard to represent your problem in it. It was a complete solution, and you could use it. And people like migrated to it like crazy. PyTorch, same thing. Like, is PyTorch the most sensible, most straightforward thing? And even simple things like, NumPy stuff. Like, you look at like, people are clamoring for, give me software to solve my problem. And so I think about libraries coming first, then frameworks coming next, and then services. And the big problem that we have with services is everybody's like finding some orchestration engine. We're going to like find something that orchestrates. We're going to take Apache Beam and we'll slap it on top of the stuff, and I'm sure it'll work out. And sometimes it does, but like, I think like the primary problem with machine learning services is orchestration. It's knowing how much of your data have you processed, where are the data as they're traveling through the system, where are the errors piling up, or where is the throughput going down? Like, these are just tricky problems for any processing pipeline, right? If I have like, you know, a terabyte of data and I want to read it and do something with it, something's going to get stuck somewhere. And if I parallelize it on a bunch of machines, then it will be hard to troubleshoot. And that's an orchestration problem. But so I think the short answer to your question is no, I don't think we'll get to a thing. But I think since people are clamoring for these things, we'll get to several things. And we'll continue to sort of, you know, we'll find some things that meet certain use cases really well and people will clamor to them, and then they'll build those into other use cases. We'll find some things that are a little bit more general but harder to use, and they'll either die out because they won't get a critical mass of people who use them, or they'll simplify in a couple of cases to make it easier for people to use. But this is how software systems evolve, I think.
Yeah. I mean, and that makes sense. That would follow the trends of history, of our short history in the software world, relatively short considering how long the Earth's been around. And I'm sure we could get into a nice philosophical discussion with you about all that good stuff. But let's go back to the idea of how machine learning breaks, and the idea that I think it's fascinating how you pointed out these ways that it breaks are not necessarily machine learning specific ways, right? You do have some of them. I'm not saying all of them. I think you, in one of your talks, you laid out like 19 different ways that you saw things breaking. And like, can we just go over that, the ways that they're breaking that you see a lot of, and how there's the machine learning specific ways that they break, and then other ways that are not machine learning that we should be watching out for?
Yeah, I think so. This is work that I did for the OPML conference, Usenix's OPML conference, with colleague Daniel Papazian. And Daniel and I looked at, putting on my SRE hat, like Google's got a really, I appreciated a good culture of, retrospectives when you have outages and looking through, writing it up and just being like, okay, had a thing, write it up. This blameless postmortem culture, which I really appreciate because it sort of treats these problems as systems problems. So we looked through, and because we do it really systematically and consistently, we had more than 10 years of outages on one particular system. Now, like, let's be honest, it's one system. And so like, who knows how representative it is? It's one system. It does one kind of thing. It has data that come from one kind of place. It's at Google, but the outages do span, depending on how you think about it, 2 or 3 completely different versions of the same system. Like the system that's solving the same problem, but swapping out all of the chunks in the middle over those 10 years. And so we're like, we've got some reason to believe it's interesting data. I can't promise it's representative. And so Daniel came up with this way of like hand analyzing these, because he had worked on the system for like 8 or 10 years. So he knew, like, he could just read the postmortems and say, oh, that's a this, that's a this. And so we went back and forth a little bit, and he came up with a useful way of categorizing them. And so one of the things I challenged us to do is say, like, hey, can we look at which ones of these would really only have been a failure that could happen in a machine learning system, whereas which ones of these are just like, bad things happen to good data even when it means well, right? And so like, there were quite a lot of that latter, and the majority of the outages and the majority of the serious outages had nothing to do with machine learning. And so that gave us some thought. And going back to, the question about skills and the, Vishnu, that you were asking, like, who do you need on these? Like, what we conclude, it was weird. We hadn't gone into this thinking like, oh yes, we as engineers, we will make a recommendation on the staffing roles for future ML team. But that's what came out. We're like, well, if you really wanted to do this better, what you would be hiring is folks with distributed systems skills, because distributed system skills are the things that are showing up that are causing the most frequent and the biggest outages on these pipelines. And they are things like, and some of those would only happen to us or people running it at huge scale. Like there are CPU bugs, salud. There are CPU bugs that you can run into only when you like get to really, really big scale. And so we're like, okay, you're very unlikely to run into weird CPU bugs that no one else has run into. But, there are other things like memory errors, or, the process just doesn't start. Why does the process not start? I don't know. You got scheduled on a machine that doesn't want to start that process. You should reschedule that task. who knows how to reschedule tasks on a distributed basis? Those would be people with distributed system skills, right? Not ML. So yeah, I didn't know if you wanted to like actually go through the specific failures.
No, we'll tell everybody who's listening, if they do want to check that out, go watch the video, that OPML video, which is incredible. It takes you through that whole journey. I just wanted to touch on that because I felt like it was so important.
Yeah, yeah.
So I know Vishnu's got another question. I see it in his eyes.
People always say this about me when they see me. I got so many stories about how my face just tells exactly what I'm thinking. But I mean, I think the point you made about the retrospectives and that culture of bringing people together to analyze what went wrong, the role of failure. I think it's remarkable that you guys have that culture. It's always, I think we all want to strive for that culture where we learn from the past, right? Because a lot of times what I see in organizations is we're like, okay, we're going to win the world next year. And to do that, these are next year's needs, right? Without really considering what happened in the past. And so my question to you kind of is like, as an engineering leader, what's your advice to other engineering leaders in terms of how to make that reflection on your needs, your team needs, and the failures, particularly perhaps in the machine learning context or not? How do you make that actionable? And how do you make that tactical? And how do you apply it?
Yeah, so I think it's an important cultural shift for many organizations. Like I've certainly been at places where we had a big outage and my boss is like, who's at fault? Because we got to fire someone. Do we? Like,
yeah.
And sometimes it would be like, literally one time it was for lightning. He's like, who should we fire for the lightning that struck the fiber? I'm like, I'm not convinced that we should fire someone for lightning. In fact, I'm convinced we shouldn't fire anyone for lightning. But I think but I know that culture of, I think there's two aspects that we talked about. One is there's a culture of blame. And the second is there's this sort of inability or unwillingness to look at past failures. And I think they're a little bit connected, right? Like, I think like if you want to survive in an organization that's blame centric, you better not spend too much time talking about what went badly, right? Because that's just calling attention to yourself. And so I would say like the ability to look at what went badly and do better is increased when you can shift away from a culture of blame. The way I've done that, and I do that sort of, I do that in my life parenting, but also like at work, is say like, hey, let's focus on systems problems. Let's have a systems thought here. And so when do you want to blame someone? You want to blame someone who intentionally goes around the systems repeatedly to try to create outages or create unnecessary risk. That's just like unprofessional, bad behavior. You tell someone to stop doing it, they keep doing it. You can absolutely terminate someone for that. But that almost never happens. Like in general, like maybe I'm just a wild-eyed optimist, but in general, like we work with people who want to do good work, who are excited to do well, and then they make a mistake. And so like you look at someone who made a mistake and causes a big outage. This is like, I shipped bad code, I shipped the wrong version of the thing. Like in an ML-centric thing, like I changed the definitions of the features in training, but not in serving, right? So you get like feature serving, training serving feature skew. Super easy to do, boneheaded mistake, right? Like, but it's super easy to do. And so when I look at that, I say like, okay, cool. Why is that easy to do? Why is that possible to do? Like, what made it possible for you to, like, we don't say like you did everything right. We say like, okay, you made a mistake and something made it possible for you to make that mistake. Something made it easy for you to make that mistake. So if I put a big red button on your desk that says, this will break everything, don't press it, and you lean over and press it, I'm like, is it your fault or is it my fault? Like, I think it's the button's fault. Like the button shouldn't be on your desk. And so that's what I really encourage engineering leaders to do, is adopt that systems approach, because I think that takes the blame out of this. That puts us back in a mode of like, let's talk a little bit about what led us to be able to make these mistakes. And then you have then you have to have the courage of your convictions, which is usually what happens after that, is people say like, well, there's a legacy system here and it doesn't have safeguards. There's another thing here that didn't know about this thing. And you're like, okay, taking a huge step back, the right thing to do is completely rewrite both of those things, because those are both terrible. like that software is not safe. That deployment system is not safe. Like this particular configuration management system is not safe. So you see that and you're like, okay, cool. Do we have the time to do that? If we don't, then we say like, well, let's be honest with ourselves. Let's mitigate this. Let's make this particular kind of failure harder to do. And then let's publicly acknowledge to ourselves that this kind of thing is probably going to happen again in a slightly different way because we didn't make the investment here. But so I think having that, like, once you take the blame out of it, you can travel through the past more often, because the next time something happens, people are like, hey, let me pull up the last 3 outages of the system. Hey, look, what about this thing? And so we do that. There's a team at Google whose job it is to try to find correlated weird big failures across multiple teams, across multiple PAs, and try to like make the case to invest in the underlying software. So if you think about like our system for RPC dispatch, right? Like protobuf, the way we dispatch RPCs among systems. If there's a fundamental weakness or problem in that system, no particular PA, no particular engineering team, no particular application team is going to be like, oh, well, I should fix the RPC system, because it's like, it's too big. They're in the wrong place. They just like build some scaffolding around it, put in some safeguards and hope for the best. And so we look at that, and I think other teams can do that as well. So that's what I would say is like, take the blame out of it, turn it into a systems approach, and that'll unlock the value of the past. And once the value of the past is unlocked, the future can be a lot better.
Well, thank you for that sage wisdom, because the reason I asked that is, I think, every professional is a leader in some sense, right?
Yeah.
In building a culture. But I think particularly so for machine learning professionals, because we are advancing a new technology, something people don't fully understand. It's incumbent on us to really be, leaders in our organizations, a little bit more so than others who might have more clearly defined roles, responsibilities, and results for the organization. And so I think a lot of times, I think ML professionals can struggle under the weight of that. And I think the things I took away from what you just said are, absolutely the systems approach, avoiding blame. And I think overall, just a structured approach to problems and how you solve them and think about them that can help you deal with all of the, just all the confusion that can be such a part of this industry. That structure, that I see, in your talks and just in general, in the companies that do this well, that do machine learning well, they are taking a structured approach to thinking about problems, and they're putting it down on paper, or they're letting others know what the structure is. So a lot to learn here, and I think our community will definitely have a lot to
and I think there's an interesting point that you're talking about on like the system design problem is it's the red button's fault for being there, right? Like that reminds me a lot of a TED talk that I saw, and I cannot for the life of me remember what it was exactly, but it talked about the systematic corruption in a place in the government forgive me if it wasn't in Albania, but I get this strong feeling that they were talking about in Albania. And the way that they fixed it was not by paying the government officials more or like punishing them more when there was corruption that was found out about. The way they fixed it was that the government officials were in this like little phone booth, and it was dark and it was all by themselves, and the design was the problem. It was that they had to bring in these a much more like designed or a thoughtful design of that, so that there wasn't this very much like isolated situation. And so I'll try to get that TED Talk and link it in the description after we're done. And it's been a few years since I saw it, but it's very much that, like, it's the design that you're looking at that's the problem, not the person who is there and being tempted or that. And so I love the way that you're looking at that. And it's really hard for me to not jump into this and go totally off track, but just ask about the famous email that has been circulating around from Google that got somebody fired, and how like that plays into this. And I know we came to talk about MLOps And I know that you are at Google right now. So if you want to just decline commenting at all, then that is totally cool also. But I wonder how that plays into all of this. It's really hard for me not to ask that question.
Yeah, no, and it's a fair question. I think it's on a lot of people's minds. I should say, like, I can't add much. Like, I don't work in the research organization, and like, I think from the outside, a lot of people think like, oh, you're at Google. So I'm like, I don't know, it's like 200,000 people. Like, yes, people do some things, some places. Like, I'm not saying I don't know anything about it, but I actually don't know anything more than what you all know about it. But what I can say is like two things that matter to me as an engineering leader at Google. One of them is that Google, and not just Google, but this whole industry should be a place where people from any kind of background can do their best work, limited only by their abilities and limited by their effort. And this is super important to me. I spend a lot of time on it. And I spend a lot of effort on it, and I'm not at all satisfied with what we at Google or we as an industry have accomplished, but it doesn't change my frustration with that. Like, so one of the things that I find frustrating is regardless of what actually happened in a situation, and and I don't really know, I do think like it is unquestionably true that in particular, Black folks in the US and women feel like they're unwelcome in this industry. And I think that's terrible. And I think like we collectively, all of us need to do something about that, because we're squandering like ridiculous amounts of great talent by virtue of like, oh, I don't think you look like the right kind of person to do this job. It's just, it's completely ridiculous, and it makes me upset. So that's one thing I can say. And I find I'm pretty saddened that that's more the case now than maybe it was 3 weeks ago. But it was already a problem, and this certainly doesn't help. And the other thing is on the role of like, I think people are lumping these together, but ethics and fairness in AI are critical. They're just like, we are going to collectively get our butts handed to us by society in the form of nation states, in the form of regulation, in the form of angry people if we don't get that stuff right. Because it's sort of like when I go back to why is homeopathy not regulated? Because it doesn't do anything. You don't have to regulate stuff that doesn't work. It doesn't matter, right? But when people started taking St. John's wort for depression, and they were like, "Wait, I have to tell my doctor I thought it was natural." I'm like, well, either it works, in which case you need to know how it works, or it doesn't work, in which case it doesn't matter. But the AI stuff works, but it doesn't work perfectly, which makes it interesting, which makes it potentially problematic. And we have to get that stuff right. On the ethics front, we need to think carefully as societies about where we want to deploy these technologies, who we want in control of them, how do we use them to democratize rather than use them to, instantiate top-down control or large, whether it's nation states or whether it's large corporations. Most of these technologies are benefiting the largest entities right now, but they don't have to. It's just because of some choices we've made about how we build these and deploy these and how we've spread the skills for them. So I think democratizing access to these technologies is critically important. That's on the ethics side. But on the fairness side, we all know that every model's wrong, but some models are useful. But there's a corollary to that, which is some models are racist, and some models are sexist, and some models are like nationalist, and some models are deeply problematic, not because the people who built them are bad people. I mean, I'm sure some people who build them are bad people, but I think mostly because they didn't notice the ways in which they had built these models that weren't doing what they found an easy way to get an answer. Their objective function didn't capture the entire stack of what they were trying to actually do. And as a result, we end up with super problematic situations. And what we know about that fairness is right now, the best way to have fairer models is to have a much more inclusive environment where more people are thinking about the impact of these models, which takes us back to we need a really wide variety of people working on this stuff. And so for me, that's the cycle. I can't comment on the Dr. Gabru situation because I don't really know anything that's not in public, but I can say it's important to me that as an industry, not just Google, I like Google, Google pays my mortgage. I appreciate that, sends my kids to school. That's all good. But the industry is much bigger than us. And as an industry, we need to be a welcoming, inclusive place for all kinds of people.
Well put. Very well put.
Yeah, I think that's exactly right, Demetrius, exactly well put. And I think, one thing that I think you've highlighted throughout this talk is that, sometimes AI doesn't work, and that's frustrating. But when AI works, it creates a whole series of downstream problems that you need to be prepared to understand and take on and allocate resources to. And that could be, analyzing failures, and it could be, understanding ethics and fairness, right? And I think that is a big lesson that, for somebody like you that's been at Google and has seen this in production for so long, that I think the rest of us, who are trying to get this into organizations that haven't used it yet, definitely kind of, could do a better job of socializing that message. One other, I guess one kind of wrap up for final question I have personally is, I think you kind of hit on this in terms of the culture of the industry writ large, not just at Google, right? And in terms of transparency and trying to be honest about the way things might fail, right? And from your experience, I'm curious, just you're certainly, a historian of the technology industry with your experience in networking and just having been in this industry for a while. I mean,
I think you just called me old, but that's cool. It's fine. I knew I was old.
Not my words, but
go ahead. Keep digging.
When you think about the trajectory of other industries and how they have managed to kind of just address, some of the public, understanding of the failures of technology, right? How do you think machine learning can learn from them? And where do you think it's different? Where do you think we're going to confront different problems as an industry compared to cellular or networking or social media or any of the other sort of industries?
Yeah, well, actually, so that's my reaction to your question is now I'm depressed because let's be honest. Do we think that the mobile computing industry ultimately was confronted for its value and impact on society, and we had a thoughtful decision about how to adopt those technologies? Or do we think people sold a bunch of stuff and now we're left with the results? Because I think it's the latter.
I think you're right.
Do we think there was a thoughtful discussion about social networking and how those platforms both connect people, but also isolate and radicalize people? Or do we think some people did some stuff and now we're trying to overcome what has happened to us? And even going back to let's talk about the way the UK went full hog on let's just have the panopticon, Foucault's panopticon. There are CCTV times millions across the UK. No matter where you are, you're being filmed by someone with control by the government or control. And you're did we have a thoughtful society-wide discussion about that in the UK, or is that just a thing that ended up happening over time? And so I guess realistically, so my job is to predict future failure. So ultimately I'm optimistic about the chances of things going badly because I've never been disappointed yet. And so I think, I hope we don't do that. I think as a society, we owe it to ourselves to try to educate ourselves a little bit and think seriously about the ways that these technologies impact society. As an industry, we are closed and we are confusing and we do not simplify and explain things very well. And I think the problem with that is that, legislators and, executives in government and policymakers have a really hard time understanding even the basics of what we're talking about. And we make it harder than we should. So we should talk and in part because we're trying to impress each other, and impressing each other isn't that useful. I'm impressed with you, it's great, but can we explain to the city councilor over there what this means? So there's some concrete examples where people are trying to do the right thing and end up doing the wrong thing. We'll talk about elimination of bail. So in the US, you have to pay money to get out of jail while you're waiting for a trial because they want you to come back for the trial and the delays are long. That seems blatantly unfair because it's imprisoning people for being poor. So a bunch of people are let's get rid of bail. Let's let people out while they're waiting on trial. Sounds good, except some of them are not going to come back and some of them are going to commit other crimes. So okay, we're going to predict which ones will come back. I think you see the problem here. All of the models that people created turned out to be racist and predict that people with darker skin would come back at a lower rate than they actually did. Well, why did they? For lots of reasons, lots of biased reasons. But you can look through policy changes like that and say, we should have explained more simply to the policymakers, it is good to not charge people money to be in jail. That is unquestionably a social good. it is also important that we be thoughtful about how we do that. And here's some simple ways to understand that. So I hope that we do a better job than we've done in the past. And I'm going to try. And I think I would encourage other people to as well. And I think the way we try is to try to, at a high level, in very simple terms, explain some choices to people. We can save these data or not. We can build a model that does this, but it might have these consequences. We can build a system that does this. Here are the risks and here are the benefits. What should we do? And to actually, and I don't think there's a lot of willingness on the part of engineers to involve policymakers, but the stuff back to the homeopathy example, if this stuff works, it's going to really work. And if it really works, we'll take it seriously. So we should take it seriously.
Well, it feels like my two worlds have collided here at the end of this chat, because I also have a AI ethics podcast that I do. Shameless plug for that. And it seems like we just got right into that. And I love that you're talking about that. You're looking at it, and you said it yourself. Your job is to predict future failures. And I think that one way to finish this off would be really nice. I know David is not here, and he loves talking with SREs about ML infrastructure, and you are like the epitome of that, right? You are the legend. And I think that one thing that he would appreciate me asking you right now is if you have any recommendations on readings or things that he could do to better hone in his craft.
Yeah, so I think the problem is we're so early in this that there hasn't been a lot written. So, I'm working on a book with some people to try to just set down the basics. But as we did the research for this book, we're like, why are there not 10 or 20 books that kind of not perfect, but when you think back to, when you wanted to learn Python, you're like, oh, there's 20 books on Python. I can pick this one or I can pick this one. But when you want to learn how to productionize a machine learning pipeline, you're like, well, there's that one over there, but it looks oddly specific. There's this other one over there that looks also oddly specific. So I don't think I'll send along a couple books, for the notes that I think are worth looking at. And there's some new ones coming out. But I think honestly, the right answer is twofold. One is you have to know the basics of the shape of the technology. Like, what are we doing? We're reading data. We're reading data to update a model. The model is an in-memory data structure that's stored somewhere, or it's on an on-disk data structure if it's huge, but it's just a data structure that's stored somewhere. We'll take a representation of that data structure and send it to serving, and we'll do some computation to look some things up. You're like, is that impossible to understand? No, it's not even actually all that complicated when you make it. I'm famous for dumbing things down. There, I just dumbed down the whole thing, but you got to know that stuff. But then the real thing you need to know is, how do you run a data processing pipeline that's terribly sensitive about its data? And the first part of that, there's some good reading, and there's some good systems work to be done. The second part of that, we're still working on. So that's what I would say. I'll send a couple links of some recently published and not so recently published books that I think are good starts. But I think, honestly, anyone whose idea is, I really want to do production engineering for ML, if that's your idea, and that's your idea right now, you're probably either going to write one of the books or be one of the first readers of one of the first books, because there's not a lot out there yet.
That's so funny you say that, because right on my desk, I've been reading, because we're going to interview on Monday one of your colleagues at Google. I don't know if you're familiar with this one.
Yep.
Did you edit any part of this? I know there's a ton of acknowledgements that I'm looking for your name. You weren't involved in it, were you?
No. But that is definitely one of the ones that I was going to recommend.
Right.
Look at. So good.
Awesome. Yeah, we're going to be interviewing Sarah on Monday, and then Lack on January 21st, because it's so true. What you're saying is that the more that you explore, the more you realize, what's going on? Where's all this? Where's the stuff that I can learn from?
Yeah. And it's just because, so that's fine. I know, as Vishnu pointed out, I am in fact old. I'm not going to let that go. But let's all remember, every technology goes through this. The internet went through this. It used to be the case that you couldn't buy a router that was able to take an IP packet on one port and put it on the other port. What you did was you downloaded an operating system, compiled it and ran it, then downloaded some software, edited it, made it make sense, built it and ran it. And when there were bugs, you read the source code and fixed it. That's for just moving packets around, right? So like, I remember back when mail servers were just a thing you had to like edit and reconfigure yourself and run. Like nobody would do that today, or very few people would. But so it's normal that this is where we are. And it's not a problem. It's just where we are. And so like, I think what people should do is pivot straight from the disappointment, like, oh, I'm really disappointed there's no book I can read. Pivot straight to, really excited, I'm about to create the industry. Where we are.
Problems as opportunities.
There it is.
Yes.
That's so awesome. I mean, I'm having a real hard time letting you off the hook right now. I know we're about 9 minutes over. So last question, I promise. Since you are in the mode of predicting things and you have this philosophical background, I'm wondering where you're seeing the industry going in the next 5 years as we do create it, as we're speaking, right?
Do you mean ML in particular, like the...
Yeah, so I'm thinking more like the tooling, and if you want to get into some ML, and because one thing that I think is interesting is the idea of like managed ML services and that whole thing, but let's keep it open for you, whatever you want to answer on that.
Yeah, so I think it's a good question. I think so. Putting on some of the experience I've had working on the services run by Google's Cloud AI division, who's really just like selling services to the world, right? So that gives me the broadest view that I can have. I don't like, each of us has our own context, so I don't want to pretend that that's representative, but that gives me the biggest view from the outside. And what I'm seeing is, I'm seeing that there's a very small number of people who are sophisticated enough to build and run their own models and build and run their own training pipelines, but it's very small. There's a larger group of people who are able to use a training serving system and bring their models and sort of build a model in a system run by other people. And I expect that to grow, but I don't expect that to be the majority of the industry. There's a huge number of people who have very specific problems that need to be solved that have two gaps. One is they don't have the skill to build, or they don't have the staffing and the technical capabilities to build the kind of integrated systems that they want to build. But the second gap they have, which nobody talks about, is they don't trust those things even when they build them. And so we take a step back. One of the things I see about senior leaders of organizations, and this is not particular to machine learning, senior leaders of organizations with some form of technology stack in them do not trust the people who are building those things. And there's a couple reasons I think for that. One is I think that most senior leaders of most organizations that have a significant technical component are themselves not educated. They do not have a background in the technology. And so they're not in a position to evaluate risky from not risky, talented from not talented, like well thought out to terribly thought out. They just don't have an ability. So as a result, what they see is these things look like magic, and when they break, they ruin my whole organization. Now, ML is like that 10 times worse. Not only these things seem like magic, even the people I think do magic think these things are magic. So like nobody knows how they work, but when they go wrong in ways that like can bankrupt me. They go wrong in ways that can like ruin my reputation, destroy everything I've built. Okay, so that trust gap is there. And I think that as an industry, we are going to have to find ways to bridge that trust gap so that if I'm the CEO of an airline, like airlines are famous for having like somewhat antiquated technology, and it's because they're so sensitive. Like if a reservation system goes down, like the airline can't fly. And most airlines, don't have a lot of cash on hand, especially today, right? And so it's not like they can tolerate a 2-day outage, stranding people all over the world because they had a reservation system go down. And so they're incredibly conservative. And this is not ML. This is just like they're afraid of their reservation system. It's just a database. It's just a distributed database with some applications built on top of it. I say just. I've worked on one of these at when ITA came into Google for a while. And so I know they're complicated, but it's way less complicated than some of the things we're talking about, but they already don't trust that. So when you say like, I'm going to set your prices with ML, it's going to be amazing. People are going to be happier and you're going to make more money. They're like, no.
Just get out of my
And so
office.
exactly. And so what we need to do, and I think we will do as an industry, is first we will have organizations, some of them like large platform providers like Google, some of them smaller providers, who take the blame. They say, I will build you that application, and when it goes wrong, you will yell at me, not your staff. And so we will use the proxy of our brand as a way of getting you to trust this. Like, do you trust Google? Do you believe that we will give you credits and fix your problems? Cool. So we're gonna do that for you. And we're already doing some, like a good example of that is the call center AI stuff that Google published that like handles call center traffic. Like, this is either terribly fascinating or terribly boring, but it basically automates the process of people chatting with and speaking with call center representatives. And there are millions and millions and millions of call center representatives. And here's some technology that makes them a little bit more efficient. If it goes wrong, it can be catastrophic for those organizations. And Google says, we'll operate it for you. You'll pay us a cut of the money we save, and you'll pay us for it because you'll be happy, because you'll be saving money and we'll be making money. And if it goes wrong, you yell at us. That's a small step towards that. So we'll have some of that. But then ultimately, I think as an industry, we're going to spend much more time, and we will have to spend much more time on model quality assertions, where we have systems where we say, if you've got a model that does a thing that doesn't ruin your life, I can guarantee you that this next version of that model will also not ruin your life. I can't guarantee you it'll be perfect. I can't guarantee you it'll be better in every respect, but I can tell you it won't bankrupt your business. Now, we all know that is a pretty steep bar. You're like, really? You're just, for an arbitrary model, you're just going to be able to say it's good or it's not good. But that is like, there's a North Star I'd like to get to.
Wow.
What a vision. I love
What a vision. Thank you so much.
Ambition.
Yeah.
Yeah.
I mean, you kind of blew my mind right there. That is awesome. I'm so happy that I squeaked in that last question. I want to thank you, Todd, for coming on here, for enlightening us to everything that you have. Just like, wow, we jumped around on so many different subjects.
That was great. Thanks so
You're
much.
Really
so
did.
versatile.
It really did. Thank
incredible.
you for sharing the time with us. Appreciate it. Appreciate you sharing your knowledge.
Thanks so much.
Yeah. And Vishnu, thank you for coming on here and helping me out, asking these poignant questions. I will see everybody later. Of course, like always, if you are not in our MLOps community Slack, jump in it. You can find the link to the description below. And with that, we are off.